Hello, and welcome to the 2021 edition of Storage Developer Conference. My name is Vikram Krishnamurthy. I work at Netflix as a senior software engineer. My role involves designing and developing globally distributed storage solutions, primarily for use within Netflix by Netflix Studio in the cloud and other internal consumers. Today, this presentation, I'm going to talk about Netflix Drive, which is a edge service or endpoint software used on artists' workstations to provide a file and folder interface, kind of a rich file and folder interface. And get into the details. Before that, I want to bring up the slides so I can talk through them. All right. So originally we had intended to have two speakers, but unfortunately Kishore could not be present. So I'll be doing the presentation by myself. And we both are part of the global storage team, which builds and operates highly scalable and distributed cloud and edge storage solutions for Netflix studios. So before I delve into the rest of the slides, I'd like to give a brief overview of the structure of the presentation. I'll talk about what Netflix Drive is, and also go over what the motivation for building this has been at Netflix. And following that, we'll get into the details of Netflix Drive itself and how it is used, kind of adding more flavor to the motivation and the definition itself. So it's a file system interface, and it's supported in multiple operating systems, Windows, Linux, and Mac OS X. And it is intended to provide a look and feel of a POSIX file system. But in addition to that, it also has behaves like a microservice with a REST endpoint and backend actions that are leveraged by studio workflows and automated use cases, where users or applications are not directly interacting with files folders. And this can happen in combination too. So it's not exclusive or mutually exclusive for each other. And the other salient feature that we took into consideration when we designed this was the ability to support or bring together various kinds of metadata and data stores and backends, and also provide an abstraction for events and alerting backends. The reason for this will become apparent when I go on to the motivation and the rest of the talk. So move on to the next slide. And so here let's start some of the motivations that kind of drove us towards building this and designing it in this way. So at Netflix, asset metadata and data are stored, managed by various systems. So starting at the point of ingest, where data is produced and out of camera, and all the way to the point where the end result or the final movies and shows are produced. So that's these the files are tagged with different are tagged with metadata by different systems based on the stage of ingestion or its stage during the workflow of the creative process. And at the edge, the artists that are working on the with these assets expect standard artists and the applications too that are running on these workstations expect a standard file and folder interface so there can be seamless access to these files, and without having to have a different agents or softwares that uh, handhold or kind of do a white glove treatment of these files by kind of involving the downloads and uploads and all those things. So the goal was to make this a very seamless experience and very transparent to the end users. In this case, could be artists, could also be automated workflow scripts, or something that runs some kind of transformations that happen on render containers or a rendering kind of work, as an example. Now, so I mentioned workflows, and these have a need to move the assets across various stages of the creative process. And typically these are iterative processes. And so moving from one stage to another involves not just carrying data that is transformed or the assets that are transformed, but also the metadata that are tagged with that in different ways. And in addition to all of this, there is also an implicit expectation that there is a level of access control that allows or projects only certain sets of files and folders to offer project to a set of team members as defined by the project and the team. So taking all of this into consideration, we kind of came up with a design for Netflix Drive, which can be leveraged in multiple scenarios as a simple POSIX file system, but also much richer controlled interface, and we'll get into details of that. So the POSIX interface mentioned is kind of familiar to everybody with any file system. So that's the expected operations that are supported. In addition to that, we have another dimension that provides APIs, and these are not mutually exclusive, as in the API and the POSIX interface. So it could be operating on the same instance of Netflix Drive, and the APIs are there to as a control interface and also a controlled IO interface. And I'll get into details of what that means in this context. So another dimension is events and telemetry information. And telemetry and logs, of course, are more self-serving for the managers, or the admins of this fleet of Netflix Drive instances that are interested in observing how they're behaving. But there's also another kind of event, which could be an audit log, essentially tracking the actions on a file that or a set of files that corresponds to assets, media assets. And finally, the other dimension is a data transfer layer, which abstracts the byte moment from any of these interfaces. So bringing in files and uploading files to the cloud. So the standard POSIX interface provides all of the read, write, open, delete, rename, what have you operations, and also metadata operations to change the attributes or query them. And this can be leveraged by applications that deal with files or users, or even scripts and automated workflows. And the API interface are particularly of interest to workflow management tools or agents that are running on user workstations that have awareness um, of the assets at various levels and can control the projection of these assets onto the namespace uh, and also perform operations like explicitly uploading to the cloud or downloading a new set of files uh, at runtime and presenting into the namespace. And events, as I mentioned, has telemetry information and also audit logs that can be consumed by upstream services that are monitoring or observing this fleet of NDrive uh, uh, processes or workstations that are running NDrive and providing access to sets of assets. And finally, the data transfer layer is an abstraction and kind of it interfaces with multiple tiers of storage. Netflix Drive being a cloud file system does not do any transfers inline. The expectation is near local file system performance. So for that reason, it does utilize local storage on the workstations if that is available. And in between these is also what we call a media cache tier, which is a region-aware caching infrastructure that brings in files closer to the instances, cloud instances, or in the edge. And you see a reference to Baggins here, which is actually Netflix's S3 access layer. So just to summarize, the POSIX interface provides the standard data metadata operations, and the API provides control and control IO operations. And eventing infrastructure provides state change updates or audit logs. And then the data transfer abstracts the byte movement. And now let's delve a little deeper into these different layers and how it is structured. And also some of the underpinnings of this design that are kind of go back to the motivation. Some of the motivation points I mentioned earlier. And before we go into that, a brief explanation of some of the terms used. These are essentially internal names of various services. So C drive is asset-aware metadata store. And it's used not just by Netflix Drive, but various other services. Baggins is Netflix's S3 data store. And media cache, as I mentioned, is a caching tier. Intrepid, which we haven't seen yet in any of the slides before, is a transport protocol. It's built by Netflix and is leveraged by various applications that have a need to move files to and from the cloud. So, so the top layer is the typical fuse layering, where you have fuse handlers for all the POSIX system calls, and similarly on Windows for the NT calls, again abstracted by POSIX. And alongside that are REST endpoints and the corresponding backend, which is kind of in the Netflix Drive agent to handle a lot of the control actions. And an important point I want to bring out here is these two boxes, which talk about abstract metadata interface and abstract data interface. So these are abstractions that allows Netflix Drive to plug and play any metadata store and data store. So it can essentially bring together a variety of data and metadata stores and project corresponding files in the namespace at a given namespace with a given namespace hierarchy. And there's even more flexibility in configuration and how the namespace is created, presented. I will get into that following this slide. And the bottommost layer is the interpret transport layer. So this kind of is an abstraction to store, move the bytes. And you also see an arrow from the metadata interface here. So in this particular example or use the interpret also proxies accesses to the metadata in certain instances to begin, like primarily to carry out the transfer operations, but that also exists, so that's why you see the line there. Moving on, this gives a different perspective of the same layering. It kind of maps it to various cloud services. So on the left-hand side, you see Netflix Drive on a user's workstation, as seen as on a user's workstation, leveraging the local storage as a staging or caching area. And on the right-hand side are all the cloud services that various layers interact with. So the POSIX interface and the API backend talk to metadata interface, which is C drive in this example, and also the data interface going back to the transport agent here, transport library, which abstracts accesses to the caching tier as well as the S3, and direct access to S3 as well. So it could be any of these things. And another thing on the left bubble is the two-factor authentication that we have. Essentially, the authentication, and given these cloud services front a lot of are used by a lot of applications, and also front the whole, in some cases, the universe of assets. It becomes essential to make accesses secure. So Netflix Drive uses two-factor authentication for one for authorization, and then authentication to various services. So that's kind of the anatomy of the structure and the design. And, this goes into the following slides, kind of talk about some of the runtime aspects and talk about the typical life cycle. And this is this becomes important because of some of the unique aspects that we have in the design. If it were a typical POSIX file system, there would be no need for specifically like talking about these things. But given the ability of Netflix Drive to dynamically present namespaces, and also the way it can bring together disparate data and metadata stores, behooves us to talk about some of these things. So at the beginning, kind of one of the things here is the bootstrapping. So it essentially controls the projection of set of assets to a particular user on a workstation. And what the assets or the namespace needs to be populated for local access. So it can be files have to be downloaded onto the workstation. So that's another action. And the user or application modifies these assets, which ultimately have to be uploaded back into the cloud, and so that it goes back into the source of truth and then is consumed by the next stage in the workflow or by another user, another artist, depending on the use case. And the upload itself happens through a snapshot where Netflix Drive automatically checkpoints modifications and then uploads them. There is also an API to explicitly upload if the user or a script or agent running on the workstation is aware of the assets and uh, is a controlled work session, then they can explicitly upload files. So more about the bootstrapping itself. To initialize a Netflix drive, user identity and user key and certificates are required for the authentication and authorization I mentioned earlier. And some of the endpoints can be specified statically. Uh, but an N-drive instance can also be brought up without any of these things specified and could be added later on through the APIs. And so for a static configuration, namespace projection can be carried out by specifying an XML or JSON file. And this essentially is consumed at startup by N-drive, and it knows what metadata store to talk to and what data store and what specific folder or set of files or assets needs to be presented. And not necessarily mutually exclusively with the static configuration. The APIs can also be added to, can also be used to add to the namespace, bring in new files and folders and attach them anywhere in the namespace, as long as the user or the workflow automation script is aware of what it's doing and where the files are landing. And the modifications, of course, can happen through the POSIX operations, users or applications opening files, reading, writing to them, changing the attributes implicitly or explicitly. And also through APIs, which are downloading files, uploading them, and kind of affecting or changing these attributes and through those actions as well. And this is an example of how files can get uploaded from the local store. As I mentioned before, a local store is leveraged for all user I/O, and in the background, checkpoint to the cloud, or can be explicitly uploaded if the workflow is aware of which files and which assets are modified and need to be updated. So that kind of gives a complete picture of what N-drive is, what the motivation for the design. And kind of we also got into details of the architecture and the ability to dynamically create and tear down namespaces. I did not mention that earlier, but applications or APIs are available to dynamically tear down namespaces as well, and then attach it elsewhere or bring in a new namespace onto the same workstation. So all of this kind of in the current state of things, N-drive is being used in various use cases, as I mentioned. So as a simple cloud store for users' home directories or application preferences, and also more sophisticated workflows where it is under the control of agents or pipeline workflow managers or work session managers that bring up N-drive, project a set of files into the namespace, and applications do transformations, and the files are uploaded back either automatically through or snapshot checkpointing or explicitly the agent using APIs. So moving on, so this kind of concludes the main part of the talk I planned. And all of this, we also published a blog, and all of this is explained there in detail. It's supposed to be a first in a series of blogs. So I've posted the link here, and expect more to come there. And also, if this kind of work interests you, we are hiring. I posted a link to the job posting. Feel free to reach out to us. And backup slides, I'll breeze through them since we're kind of nearing the time limit. Just shows you the look and feel on OS X in this case of what Netflix Drive looks like, and a mapping of assets, the realm of assets to files on user workstations, and then back as assets on the other end. And some call flows within Netflix Drive, different layers of Netflix Drive, and how it ends up, how files created, modified, end up in the cloud or back onto the workstation. So this is a save or upload workflow, a call flow. So that brings me to the end. Thank you very much. Thanks for listening to the talk. And also a shout out, because I'm just a spokesperson talking about Netflix Drive, but we have a team of engineers who are passionately working on this and bringing in new features, and we'll probably write about them in the blog. Thank you.